morning everyone. This video is going to be following me as I diagnose an issue with this outboard engine. It's going to be a bit less of an instructional and more of just following the process and some helpful information for someone who might be doing similar in future. So this is the Yamaha 30D again. I'm having an issue where it coughs and splutters on idle. I'll show that video now. So that was particularly bad. I believe this is what's called a lean sneeze. So you were seeing some of the previous videos. I'll show a snippet now. It does occasionally hiccup at idle. And that's usually the symptom that I get. However, I've found that after running at slow speeds, so say coming into a boat ramp or something like that, so prolonged time at low speed under high load, so you're like 5 to 8 knots, I find that it is very, very bad. It presents itself, which I'm assuming is when the engine heats up. There's less flow of water through the engine. You're under high load. I assume that's what happens there. So with some history from this engine, so I bought it about a year ago quite cheaply. It had been sitting for a very long time, and there was gummed up shit in the carbs. I gave them a basic clean and did a carby kit with a non-genuine kit. I found the quality of that kit a bit funny, like some of the seals were a little bit funny to fit. So anyway, on a sea trial after that, I found that I still had some crappy engine performance. So erratic idle. It was very hard to come up onto the plane. It would sort of bog down heavily and then it would just take off with a load of power at once. So I brought them back, did another clean out, a bit more in depth this time. I replaced it with a genuine carb kit and I also replaced the pilot jets because they were very hard to clean, very small, and they were gummed up as well. So once I'd done that, and then I ran through the Yamaha tune and adjust procedure as per the manual, the engine's been running okay since then, particularly at open throttle performance. I'm quite happy with how this boat performs on a day where I'm averaging, say, all up for the trip 15 knots. I'm using about half a litre per nautical mile. And the wide open throttle performance is just under 5,000 RPM. I'll be reaching about 23 knots. So I'm quite happy with that with this boat. But I still have and always have had, a bit of a crappy idle. When it's cold, it's not as bad. It stumbles along a little bit, but definitely when you get it in that hot condition, it's particularly bad. So one thing that I have found that's a key piece of evidence is I can virtually, if I disconnect the coil to number 1 cylinder, it makes zero change to the idle. So cylinder 1's effectively doing zip on the idle. I did find that out yesterday in a bit of a sea trial. So now we're just going to follow through some of the steps that I've done so far and prior to that and what we found. So to test the health of the spark system, we're going to use one of these little spark testers here. You could pull the spark plugs out of the engine and leave them all connected and watch for the spark. However, it doesn't really show you the strength of the spark. You don't really know how it's operating there. And you also can sometimes get a shock. I've done that. It bites. So yeah, get one of these. It costs you about $20 from any auto store. And in the manual, it states to use one of these devices to check for the spark. So you've got to remember that the spark plug gap on these plugs is 1 millimeter. What it asks you to check here is it checks it up to 9 millimeters. This is checking the strength of the spark. So I've set mine to 9 here. You can see that, that's on 9 millimeters. What I've also done is got a little plastic stopper here that I've got to the right size to at least put some tension on this pin. I found the continuity was a bit sloppy in this socket. It's very cheap. So anyway, that sort of holds it in position, means I don't have to monitor it if I bump it, and allows me to test the spark. Okay, so these are really simple to use. In the manual it states we should get about 9 millimeters while cranking. I don't have electric start, so I'll just be pulling it. All you do is you connect the coil directly into there, and then you connect this to a good known ground, which here is this ground here. The way I do this is you have to have the kill switch in to enable this circuit, but to stop the engine from running, I just disconnect the 2 coils for the other cylinders like that. So now the engine won't run. So when I do pull it, we should see that spark, and then we can judge it from there. So we'll now do that for each cylinder.
As you can see from those tests, all 3 cylinders have passed the 9mm gap test. So you can fairly say that the spark is healthy for all 3 cylinders. I did, however, do some more tests, just generally check some resistances around the ignition system just to make sure there wasn't any obvious issues or huge discrepancies. So firstly, I actually tested the ignition coils themselves. The resistance I had between the wire from the CDI to ground feeding into the coil, I had low resistance, about 1 ohm on each cylinder, so that was good. And then I also tested the resistance from that CDI wire to the actual plug and cap, the high tension side. So I found there that everything was in the similar ballpark, between 13.6 and 15.8 kilo ohms. There was some variance there, which is a little bit odd, but I'll leave that for now. Everything seems to be working healthily, and I suppose it's probably okay in that range. I was more just looking for either a short circuit or an open circuit. The other tests I did as well was just checking on the CDI side of things, the pulse and trigger coils. So they all came in at the same at 345 ohms, and then the charge coil at 493. So everything from the ignition and CDI side looks okay. And then obviously we're getting that healthy spark. So we can basically, at this point, more or less rule out, or it's highly unlikely that there's any problem with the ignition system.
I've also checked now a couple of times with the engine nice and warm, the compression across the cylinders. So I got between 100 and 105 PSI across all 3 of these cylinders. So I believe that's adequate. So we're getting spark at the correct time and it's strong. We've got compression. The only other thing we need here for combustion is correct amount of fuel delivered. I'm semi-confident in the carburetors because of the wide open throttle performance as well, and I've cleaned them a couple of times. I will be looking at that again though. What I think now potentially is the reeds in here may be stuck. So that's what we're going to look at today. So I've just done a little bit of a visual inspection on these, and to be honest, nothing is immediately seems to be of an issue. Everything does look okay. Just going to go through and sort of tap these now and see if we get any changes in noise or anything like that. Okay, so those all feel pretty good. So there's potential that this is not my issue. But for now as well, this is just the number 1 carby that I've just pulled off here. I'm just going to quickly strip this and have a quick look and make sure there's nothing untoward going on there. And I might look at doing a bit of a long clean in the ultrasonic cleaner for it. This is the number 1 carb. I've removed it from the assembly. I'm just going to strip this down and we're going to give it a nice clean. So for starters, I've cleaned all the area, given it a wipe down. I like to use a lot of rags while doing this because you want to keep everything as clean as possible to give this the best chance. So the only thing I've taken out so far is this little drain from the bottom of the carby. So we'll continue to strip down. So first thing here I'm going to take out is the idle mixture screw. So that just comes with a little spring on it as well. Looks in okay condition. Next I'm just going to back this off just so while we've got a flat base on the carb, I'm just going to make sure that's nice and loose. Now we can flip the carb over. And take out these. These are actually JIS I think, but I've cracked them and they're coming loose. Just be careful. Taking off a carb for the first time, you can easily strip them if they are JIS, which a lot of them tend to be, which is slightly different to a hex. So that's our bowl removed. Quick look in there, everything's looking good. I'm going to leave this gasket on here, it's not that old and it looks in good condition. They usually come in a carby kit. Now we've got the float, the main jet, and then this actually opens up the passageway to the pilot jet. So we'll take the float off. Just take out that screw. There's a little bar that goes through here. I'm just going to get a very small punch. And, actually, use this scribe that I've got here just to pass that through. Once that bar's out, the float then releases. This is a pretty common wearing component. This is the needle. Once again, this is in good condition. It's all quite new. Okay, now we're getting into the interesting parts. Okay, so luckily I've taken these out previously, so they're not probably too bad. You have to be careful though, it's quite a wide flat, wide but thin flat, that one. Yeah, that is the correct. So that's the main jet there. Now this passageway here, that just takes out that little screw cap, and then deep down in here is your little pilot idle jet, which I'll remove. These can be quite hard to get out if they're gummed up and in there. They sit nice and deep. So this is the pilot jet here. And I don't even know if the camera will pick it up, but the holes in this thing are tiny. See if I can get that so you can see the light through it. Also having a look here at the moment very closely. You can see there's a very, very, very small piece of shit that's jammed in this pilot jet here. Very, very small.
So unfortunately I stopped recording. The part that I missed was removing that little silver plate that I showed, I loosened it first on the top of the carb, which you take a couple of small seals out, little almost like a foam plastic seal, and then that exposes the airways to the idle circuit as well as the main air jet and the pilot air jet. These are very hard to get out. I've found they get pretty wedged in there, so I wouldn't recommend trying to remove them. They're quite easy to clean in situ, but if you do want to get them out, which I have done for this video, you can do that. And we'll show now a little layout of all the different jets.
So I've just got here laid out all the different, I suppose, jets and the sizes per cylinder once they've been removed. So you'll see that I've got a new main and a pilot in here, and then the air jets are the ones that are a bit older. So this is the carburetor here. So obviously the throttle this side, that's the choke. So here we've got, this is where the main jet sits, and this is where the pilot jet sits. So these are both fuel. The fuel's coming up from the bowl up through these passageways. You can see that there's multiple drillings through different stages of these. I'm not going to get too much into the complexity. We've obviously got the air that's being drawn into the engine naturally, but then there's also these air jets. So this is an airway, open to air passage that comes through. Here where the M is, that's where the main air jet lives. That's where the pilot air jet lives. So now the carby's stripped and just waiting for the water to come up to temperature there in the ultrasonic cleaner. Just have another look here at these reeds. One thing I have noticed is, see if I can get this on the film. Wait for the camera to focus in there, maybe. You might be able to see is some debris like this floating around. So I found some pieces like this debris, which is from the actual gasket. You can see it's a bit of vacuum leak in here. this is the hole that goes through to the fuel pump. So I'm definitely going to take these reeds off, give them a good clean, and then replace that gasket. I've looked, I can get it online for about $30, so I think that's a safe bet. This is the number 1 cylinder. You can see that black debris. There's a little bit in number 2 and 3, but 1's got the most in it. That's from that gasket, so that gasket's definitely pretty toasted.
So I jumped online and I've ordered one of those reed block gaskets to replace. While I was at it, I think it was only about $25 a set for the reed petals themselves. So I'll replace those just as some preventative maintenance. The ones do appear to be in good condition. I did strip down number 1 reed block, and there's some very, very slight deforming in those, like only minor. It's probably okay, but I thought, while we're here, we may as well just replace it and give the engine the best chance at some smooth running and better performance in the future.
Loctited in here. The first one, I cracked it with the manual impact screwdriver that I have, and then it was still super tight. I was like, I think these are Loctite in. I looked in the manual, and yeah, Loctite 271. So they need a bit of heat. So I did put a bit of heat on the back of them, but I didn't want to go too hard and cook anything. So yeah, I ended up doing that. That helped a little bit, and then just taking them out with that impact was okay. So having a closer look at this gasket now, so you can see that's actually bubbled pretty badly there and here. So these channels in the back, now lift this off, back the device up a little bit. So if I lift this gasket off, you'll see there's all these galleries. That all links to that this hole here for the fuel. You see there that goes. So that's yeah, allows the fuel pump to run. But maybe there's some issue there. You can see that it's pretty buggered looking, to be honest. Like, yeah, I think that's this will be a replacement. This one.
So I replaced the reed block gaskets and the reed pedals, and I put everything back together, and once again it was running okay, but I was still getting that funny lean sneeze. Long story short, there's a part in the manual which says to pay attention to the pilot circle screws, fuel adjustment. So I just decided, you know what, I've done enough on this so far. I'm just going to order 3 of those new and see what happens, because I'm still getting that sort of lean sneeze symptom. I put those in. I went back through and set them as per the tune procedure and checked a few things, and that has solved my issues. So that was probably it all along, but regardless, at least I've replaced a couple of parts there that were starting to wear, like gasket, and learned a lot about the outboard. So yeah, that was the end of it. Let's just checking those if you do have these issues, and hopefully through this video and stepping through the process and by sharing some of my test results, hopefully somebody can diagnose an issue with their outboard. Thanks for watching.